Hello, today we're going to solve a problem on a conservation of momentum. Let's start by reading the question together. A pendulum is constructed by hanging a wooden block with a mass of 5 kg at the end of a rope. When a bullet with a mass of 50 grams traveling at a speed of v embeds itself into the block, the bullet plus block system rises by 80 centimeters. Calculate the speed of the bullet v before it hits the block. Okay, so we are given a block that's hanging on a rope. We fire a bullet which is traveling with a velocity v, and while the block is stationary, it hits the block, and together they start traveling with a speed of capital V and rise to a height of h, which is 80 centimeters. So we have to essentially deduce what was the original speed of the bullet. Okay, so how do we solve this problem? Well, we're going to invoke the conservation of momentum. So momentum is conserved, and how do we express it through equations? Well, momentum is just mass times velocity. So before the collision, momentum of the bullet is m times its velocity, plus momentum of the block times its velocity, which is 0, because block is just hanging here. After the collision, bullet gets embedded into a block, and they together start moving with a combined velocity of v. So momentum is going to be their combined mass times velocity. From here we can deduce that velocity is equals to small m times v divided by m plus capital M, right? So keep in mind here, momentum is conserved, but energy is not necessarily conserved. Why? Because when bullet hits the block, it loses some of its energy because it does damage to the block, right? So that consumes some energy. So we cannot use the conservation of energy at this point, because you hit the block, you're breaking pieces of the block, and also you increasing its temperature. So energy is definitely being lost into heat and this damage. But after the block is embedded, now there is no destruction is going on or no heating is going on. So after that, energy should be conserved. So energy is conserved during the rise. So here what we're gonna do, at this point we only have a kinetic energy, which is mass, and in this case it's a combined mass times combined velocity squared divided by 2, and it will rise up to a point where block cannot go any higher, meaning its kinetic energy at this point at certain height h becomes 0. So this is the maximum height that it can rise, and at that point the only energy we have is a potential energy. This is again mass, in this case it's a combined mass times g times the height, right? So from here we can cancel m plus m's from both sides, multiply both sides of the equation by 2, right? And we end up with v squared equals 2gh. Well, we already know that the capital V is equals to this. If you put it in here, that's what we have. Now we can solve for a small v, which is a velocity of the bullet, and it comes out to be small m plus big M divided by m times 2gh. And if we plug in the values that are given here, 50 gram for the bullet mass, 5 kg for the block mass, 10 for gravitational acceleration, and 8.8 meters, because it's 80 centimeters, for the height, and divide this by the mass of the bullet, which is again 50 grams, we end up with 401 meters per second. So that's the velocity of the bullet, and that's the answer to our question. Thank you.